Hi everyone. In this video, we are going to see three simple C programs based on the concept of operators. Number one, enter number as odd or even without using arithmetic operator. Strictly, we should not use modular division operator here. Okay, then how we are going to perform this? By using bitwise operator. So what is my bitwise operators? The operation we perform based on the bit value. We know whatever may be the values, it may be the image or text or number. In the memory, it will be saved in the format of binary representations, which is nothing but zeros and ones. Okay. So here, what is our input? Any integer, one integer here. We need to represent this integer in the binary format. What is the general format here? We'll start from the 1 and double of 1 is 2, again double like this. Okay. Now, so we'll represent 10 in the binary format. So among these four numbers, what are the two numbers we should add to get exactly 10 here? So 8 plus 2 is 10. So in those places, we'll make it as 1. Okay, right. In remaining places, make it as 0. Right? I'll take one more example. We'll take 11, which is odd number. Okay, fine. How do you get 11? 8 plus 2 plus 1. So in those places, make it as 1 like this. Okay, right. And here it is 0. Now, if I'm telling that 1010, this is a representation of 10. Suppose if it is 1011 means it is 11. Okay, right. So doing the operation over the bit value, we need to go with the bitwise operator. What are the bitwise operators are there? What are the operators are there in bitwise? AND, OR, XOR, shift left, shift right. Okay. See, we have 4 bits here. Each and every bit holds the value of either 1 or 0. Right. So, look at the general format. Except the extreme right bit, other numbers are even number. So, if I'm making here 1, it means it is odd number. So, what I'm telling, if it is 17 or 19 or 21, definitely the rightmost bit value will be the 1. That's for sure. Understood? Suppose if it is 20 means the rightmost bit value will be a 0. Okay. So what I'm going to say, it is enough to check whether the rightmost bit value is 1 or 0. If you know the answer, we'll come to the decision regarding odd or even. Okay, fine. So how to find the last bit value, either is 1 or 0, by using the operation of bitwise AND. Okay, our input is 10. We'll do AND operation of 10 with the value of 1. What is the one value representation? It's simple, right? 0, 0, and here it is 1. Okay. And I'm taking the second example also. 0, 0, and 1. First we do 10 and 1. What is AND operation? Both bit should be a 1. Only then the result is 1, right? Okay, sorry. Here. Both bits should be a true. Only then the answer should be a true. Okay. Here. Even if either is 0, the result is 0. Okay, fine. So now look at the answer. What is the final answer? 0, 0, 0, 1. Okay, it means that is 1 here. And coming to the 11, let me explain what is a bitwise operator. So if we perform the operation over the bit value, that is called a bitwise operator. Okay, what are the bitwise operator? Shift left, shift right, bitwise and bitwise OR, these are the operators, right? So here, first we'll wrap whatever may be the data, it may be the image or text, it will be stored in the memory only the format of binary. That is nothing but 0 and 1. Okay, what is our input here in this program? Integer. How many integer? Only 1. So let me take an example like this. So our input is 10. I'll take one more example. Our input is 11 here. Okay, right. How do you represent 10 in the binary format? Very simple. The general format is what? To make it as a bit form, 1 double, again it's double, again it's double. So 1, 2, 4, 8, something like that. Need to bring 10 here, right? So among these four numbers, what are the two numbers we should add to get the 10? So 8 plus 2 is 10. So in those places, make it as 1 here. Okay. and remaining places make it a 0. 0, 1, 0 is a binary format of 10. Or coming to 11, again, how do you represent 11 now? So 8 plus 2 plus 1, that is equivalent to 11. So in those places, make it as 1. Okay, right. And coming to here, this is 0. Understood? Now, so look at the general format again one more time. See, except the last bit, remaining numbers are even number. So except the last bit, I mean rightmost bit, remaining numbers are even number. Okay. If you are planning for representing any even number, definitely the rightmost bit value should be the 0. Correct? See, look at the example of 10. Rightmost bit value is 0. Suppose if you are writing for any odd number, rightmost bit should be the 1. Understood? So it is enough to find what is the value of the rightmost bit, whether it is 1 or 0. Okay, fine. How we are going to find? Yes, using the operation of and with the value 1. I'll tell you why we are choosing operation with 1. Because 1 holds exactly 1 on the right hand side, rightmost bit. Okay, and the rest of the bits are 0. That is the reason we are choosing 1 there. 0, here it is 1. Now we perform the AND operation between the 10 and 1. Okay, we know very well what is AND operations, right? The result is purely based on the 2 bits value. That is, if both the bits are true, means the result is true. Here is 0 and 1. So 0 will be coming, right? Both the bits should be 1. Only then we can say the answer is 1. Okay, here 1, 0, 0. 0, 0, 0. Here also 0. So all the 4 bits are 0. The end result is what? Again 0. Understood? Right? If you represent these 0, 0, 0, 0, so value is what? 0. So coming to the next example, I'm planning for doing AND operation between 11 and 1. What is 1 representation? 0, 0. Here it is 1. Okay. Here, look at the last bit. In the both bit values, we have 1. So final answer is what here? 1, 0, 0, 0. So how do you represent 0, 0, 0, 1, 1? That's it. So what is the inference? What I'm going to say now? See, if you perform AND operation with 1, the end result will be 0 when the input is even number. If the input is odd number like 11, 17, 18, the end result is 1. That's it. This is our idea. What is operation? Bitwise AND. With back number 1. Understood? We'll convert our idea into the program now. So this is a program number 1. I'll delete this command line to have a better space here. Right. We'll receive one input. To store input, we need a variable. I'll go with some variable here. Okay. Integer A. We'll give some prompt messages. Say enter any number. We'll scan this. In the ampersand of A. Now, we got output from the user in the variable of A. Okay. Now, we need to check the condition whether the AND operation gives the result 0 or 1. Okay. Right. So, AND is our input. Sorry. A is our input. AND is our operation. With 1 is equal to 1 or not. That we have to check it. If it is equal to 1, definitely our input is going to be the odd number. Okay. Right. Else, so printf, the result is what? Even. That's it. We'll run this program. Any number. I'll go with 10. Yes, it is even. One more test cases. It's 11. Yeah, it is working properly. Now let us move to the program number 2. We don't want to waste the time. Okay. Or else I'll give this program. I'll show this program once. Here we can take a look of this. I know it is very simple. Anyhow, this video I'm designing for the beginners, those who are doing first year, those who are very weak in program, even the guys who are doing intermediate or +2, +1. Okay, right. We'll move to the program number 2. So finding here is leap year or not. Some of you may think that it is easy program, sir. If year is properly divided by 4, then it is a leap year. You may tell like this. No, it is not right. And there are some criteria. I tell you briefly now. So first conditions. So year is leap year. Then the year is properly divisible by 4. Okay. As well as we need to check one more condition. What is the one more condition? Yes, the same year should not divisible by 100. Should not divisible by 100. Let's say 2100. 2100 is divisible by 4. But it is also divisible by 100. So it is not a leap year. It is non-leap year. Understood? Right. So coming to the criteria number 2. Okay. What is criteria number 2? We don't want to check with the 4 or 100. Straightly, we have option to decide based on divisible by 400 or not. If some year is divisible by 400, we can say that year is definitely leap year. In that case, we don't want to bother about whether it is divisible by 4 or 100, something like that. Understood? So we have just two conditions. Right? So in the first program, we have used type of operator, bitwise operator. Here we are going to use logical operator. Okay. We will be using AND operation as well as the OR operator in the single line. Okay. Right. So what are the criteria I told? The two criteria. Number 1 and 2. What is number 1? Number 1 includes two conditions there. Okay. So we'll make it as two conditions. So have you noticed while explaining the criteria number 1, I said that as well as means what? Both the things we have to take into account. It means this and that. So logical AND operation should be there. Okay. Right. So before that, we need to get input, right? We need a variable. So let it be year, integer. Okay. So we'll give some prompt messages to the user saying enter any year. You may feel that I'm going a bit fast. Yeah, I understand. But since it is very easy program, you have to follow very quick type. Percentage D, comma, ampersand year. Yes, we have received input from the user. Next, checking all the criteria using the logical operator. First criteria, do you remember? We have to check whether it is properly divided by 4 or not. How to check properly divided? Modular division. What is the answer of modular division? Simply it gives a remainder. For example, 5 modular division 2. What is a remainder? 1. 1 is an answer. Understood? So modular division means it gives a remainder. For example, I'll give one more examples. 9 modular division 3. What is the answer? No remainder. So 0. Okay, clear? Right. Suppose the year is 2025, modular division 4. What is the remainder? 1. Because 2024 is properly divided by 4. Again, we have one more in the 2025. So that is remainder is 1. Understood? Right. So if remainder is 0, we can tell it is properly divided. Okay. Right. What I told about the second phase in the first criteria, it also should not be divisible by 100. So we have to go with AND operation. What is the symbol here? Double ampersand. Okay. Here not equal to when divided by 100 not equal to 0. This is one condition. First criteria. Whether this condition should be true or else. Or means logical or. Okay. Or what is the one more criteria? The year is divisible by 400 or not. Okay. If it is divisible by 400 or it satisfies the first criteria, we can say it is a leap year. Okay. Right. So printf will give the result as leap. Okay. Else non-leap or not. 2025 is non-leap year. I've told one example in between. 2100 is leap year or not? It is non-leap year. Correct? We'll check this. 2100. Okay, non-leap. Yeah, everyone knows that 2024 is a leap year, the previous year. Okay, right. So 2024 is leap year. Correct? So our program is right. Now, I'll keep this program in one screen. It's simple. Okay, right. I hope it is very easy to understand. We'll move to the program number 3. Okay. So we are seeing the concept of operators. These are the very basics programs, okay? So find a number is perfect square or not. It's a program number 3. Fine. Without using loop. What is the idea? We have some input that is integer. We try to find the square root of that number. Okay. So that will save in some variable. Let's say a. See, our input is a. Fine. Okay. And we are going to find the square root. That will save in the variable called b. Okay. What is b? Okay. B is what? B is square root of a. Understood? A is what? Input. Okay. That is integer. Fine. Now how we'll decide if b is equal to, sorry, b square is equal to our input means, easily we can say that the entered number, that is a, is an perfect square. If it is not equal to, means we can say that it is not a perfect square. Understood? So we'll develop this idea in the coding now. We'll get one input. Okay, we need one variable. Let it be a. Give some prompt messages saying enter any number. We'll scan this. Ampersand a. Understood? Right, fine. So what we supposed to do now? We have to find square root. How to find the square root? Using inbuilt functions. Okay. So integer b is equal to sqrt is the inbuilt function that is available inside the package or library of math, square root of a. So here, listen, square root is a function, inbuilt function available in the math library. It will return the value in the format of, in the type of integer. It will return in the integer format that we are saving in the variable called b. Now I am going to check that b star b is equal to a or not. If it is satisfied, we can tell it is a perfect square. Okay. Perfect square. If this condition fails, easily we can tell it is not a perfect square. Not. Simply I make it as not. Okay. Not. We'll run this program now. Okay. Enter any number. 25 is perfect square. Yes. We are getting properly. 26 is not a perfect square. Okay. 26. Not. Fine. So we got the result. So now we have discussed all the 3 programs. So I hope it is very easy to understand. So if you want discuss anything, so you can put it in comment sections. Okay. See you all in the next video. So before this, I'll keep this in a screen. You can take a look or a screenshot or even pauses and you can go for analyzing things. So thank you all.